With Apex 2012, several new features have been added to the program that improve ray trace capability. First, the program now automatically recognizes when the geometrical description of objects can be simplified, resulting in a faster ray trace without sacrificing accuracy. Also, the program can now do partial ray tracing. This allows users to propagate rays through the system one surface at a time, or from a particular surface to another. Using this new feature, users can now evaluate light performance at any point in the system. Finally, a new move and focus capability has been added to the program. This allows users to automatically compute best focus for a beam, or to move rays along their current direction vectors. With these two new features, users can now study spot size or image size as a function of defocus. Let's take a look at some of these features. Here I have half a binocular system, comprising a doublet objective and two prisms. Let's suppose that I want to do a partial ray trace on this. In the Trace menu, I select Step Trace, and right here I specify the number of steps. A step is defined as a single ray surface intersection, so for instance, a singlet lens would involve 2 steps. Let's suppose that I want to go from the source through this doublet lens, which is 4 steps, to the front of the prism here. In that case, I set this to 5 and click on the Step button. As specified, the rays have stopped at the front of the first prism here. You'll also notice that in the Property Manager screen, there are 2 options, through surface or up to surface. This means that the ray stops just after the surface or just before the surface. Now let's suppose that I want to continue by going from the front of the first prism to the back of the second prism. Let's count the number of steps involved. 1, 2, 3, 4, 5, 6, 7. Keeping in mind that the 2 prisms are not glued together, so there's a narrow air gap here. Over in the Property Manager, I set the number of steps equal to 7, and then click on the Step button. And we can see that the rays propagate to the back of the second prism. Of course, counting the number of steps can sometimes be tedious, but we can avoid that by using the From To option in the Step Trace dialog box as shown here. These 2 windows are used to select the start surface and the end surface. In this case, I'll start at the front of the first prism, and then I'll end at the focal plane down here. Once I set the 2 surfaces, I click on the Step button again. Now that we've seen what Step Trace can do, let's take a look at Move and Focus. We can see here that the detector plane is out of focus. Suppose that I want to compute the best focus position here in order to better locate the detector plane. I go over to the Optics Manager, right-click on the Ray Trace item, and choose Focus. The default is to just compute the best focus point. As we can see here, however, the user also has the option of propagating rays to that point, or to propagate the rays either forwards or backwards to a sphere of arbitrary radius. We'll just use the defaults and click on the OK button. The lower window in the split screen view displays the X, Y, and Z coordinates of the centroid point, and also the RMS deviations. Basically, this is related to spot size. Now let's suppose that I want to move the rays to this position. One way to do this is by selecting the Z coordinate of the centroid point, right-clicking, and then doing a copy. Going back to the Ray Trace item, I right-click, and this time select Move Rays. The Move Rays dialog box has several options. We can propagate the rays along their current direction vectors by a certain distance. We can also propagate them to an X, Y, or Z plane at a certain location. Alternatively, we can propagate them by a certain optical path length. And finally, we can propagate the rays by a relative distance along the X, Y, or Z axis. In this case, we'll propagate the rays to the plane of best focus as computed by the Focus command. I come down here and click OK, and the program reports that the rays have been moved to that location. Let's confirm the move by going to the Analyze tab and choosing Position Statistics. We can see in the lower window that the rays are now located at the best focus position. In the same way, we can use the other analysis options such as irradiance to evaluate spot size, irradiance at best focus, or intensity distribution at best focus. To summarize, these new features, step trace, focus, and move rays, allow the user to characterize the light at any point in the system.